take out a blank piece of paper. And on top, if you would write prime factorization. Prime factorization. This has a bunch of different names we use for it. It's also known as AKA product of primes. And sometimes we call it lovingly and affectionately the tree thing. But before we do that, we have to understand we talked about this before. What are prime numbers? If you look in your notes, which you shouldn't have to, remember the prime numbers? Frankie did the 12th prime number was 37. So if you remember, prime numbers are numbers that you can't break them down by dividing them by other numbers. They only have two factors. So the prime numbers are 2, 3, 5, 7, 9, 11, 13, and they go on forever. But if you know those first, whatever, 2, 4, 6, whatever, those are the best there. Wait, do I have that wrong?
Isn't 9?
Oh, I'm sorry, 9 is not a prime number. Yeah, let's skip the 9 part of that. So, Kelly, what are we looking for there? Huh? Did you just start jotting notes down? I'd say because turning the pages is starting to make me think that something's going wrong. Now, the opposite of prime numbers, did we jot those down? I think we did. If you look at the letter C, we have what's called composite numbers, yes? We did write that down, right? And composite numbers would be the other ones that aren't prime. So the number 4, the number 6, 8, 9, 10, 12, 14, 15, and they go on forever. Okay, just make sure you got those in your memory bank because you need to kind of keep that stuff straight there. Now, what we are doing when you're asked to prime factorization, the book has been giving you hints up until this point. Prime factorization, is breaking a number down so that it is the product, which means the answer to a multiplication problem. It is the product of all prime numbers. Oh boy. Which will make no sense to you until we talk about it. But I just thought I'd throw the definition at you there. Prime factorization is breaking the number down so that it is. And I don't remember, let me get rid of this. I don't remember what problem it was here, but the book already had you do this. I guess we can't do that, can we? The book already had you do that when it gave you, I believe it was 9, what were the numbers? Today's assignment. They told you to write 9, 10, and 12 as product of primes. Which meant we did the number 9. 9 equals 3 times 3. Those are both prime numbers, and when you multiply them together, you get 9. We did 10, and that's pretty easy because 10 only has 2 factors, 2 times 5. Why couldn't I use 1 times 10? Because neither one of those are prime numbers. This has to be only prime numbers. Okay, so it can't be 1, because 1 we said was neither prime nor composite, and 10 certainly isn't a prime number. And then 12, well, you could write 12 is 3 times 4, but you can't have 4 because it is not in our list of prime numbers. So it's a composite number, so you can break it down some more. What times what gives you 4? 3 times 2 times 2. Okay, if I were to remultiply all these, 3 times 2 is 6, and 2 times that is 12, I get 12. Okay? Yes, Mr. Hahn, that sounds exciting.
Yes, that is very exciting.
Now,
Teach us.
here is a little bit in how you do this. The reason we call it the tree thing, there are two ways to go about prime factorizing. To prime factorize. One of them is a slightly more popular than the other. Way number one is what we call the tree thing, which is really called a factor tree. But tree thing sounds more sixth graders, I guess. Tree thing, which is a factor tree. Why do you suppose it's called a factor tree? Because when you do it, it looks like a tree. Now let's look at 12. Let's do 12 again as a factor tree. Here's how that would work. Okay, you have the number 12. You just have to say to yourself, what times what gives me 12? And there's a couple different answers. You could say 6 times 2. You could say 4 times 3. 4 times 2. Yeah, you do it, whatever. You could 6 times 2. Let's do 2 times 6. Okay, so it looks a little like a Christmas tree starting off right here with branches. You can stop when you get to a prime number. On that branch right there stops because 2 is a prime number. But 6 is a composite number, so if it's a composite number, you have to keep breaking it down until you only get prime numbers, and then you say to yourself, what times what gives me 6? Well, there's only one way to do that. It is 2 times 3. Now, is 2 prime? Yes. Is 3 prime? Yes. And those, the bottom branches of your tree, are your prime factors. When I remultiply those back again, I will get 12. And again, I didn't have to go that way. I could have done 3 times 4 as my first 2 branches of my tree. 3 is a prime number, so I can stop at that. But 4 can be broken down into 2 times 2 till I get to my prime numbers. And there we go. It's the same numbers, 2 times 2 times 3. Now they get more complicated than that. Let's do 24. 24 as a factor tree. What times what gives me 24? Trevor? Pick any. 8 times 3. You look at your branches. Are either one of those prime? Which one? Victoria? 3. And I would highly recommend circling it so you don't lose track of it. 8 is a composite number, so I have to break that down into what times what, Andrew?
4 times 2.
4 times 2. Are those both prime? 2 is, but 4 can be broken down some more. What times what is 4?
2 times 2.
2 times 2. Please don't use 4 times 1, because 1 is not a prime number. And you don't get anywhere, because you could keep doing 1 times 4, 1 times 4, 1 times 4 till for the rest of your life, and I don't want to spend the rest of your life doing this factor tree thing. So those are both prime, so I can stop. I have nothing more to break down. So my prime factorization of 24 is 1, 2, 3 2's and 1, 3. Which, if I remultiply that out, 2 times 2 is 4, times 2 is 8, times 3 is 24. I go back there. And then please, 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 to help all of us out, Jordan Shaw, help us all out, write these, when you write them down, write them in order from least to greatest. Don't just leave them like this, because when I read the answer, I'm going to say, 2 times 2 times 2 times 3, and I don't want you to have to go, oh, there's a 2, there's a 2, there's a 2, there's a... Just write them out in a nice little order, and everybody will be relatively happy. Let's see what else. I'm missing something here. Let's do one more. Let's do the number 60. Let us do the number 60. We still got more to talk about. Let's do 60 right here. What times what gives me 60? And you can pick anything that you know. Victoria says
6 times 10.
6 times 10 is fantastic. Are either one of those prime? They are not, so I got to break both of them down. What times what gives me 6? Kelly?
3 times 2.
3 times 2. Are those prime? Yes, they are. So I can stop, so I'll circle those. I'm done with that part of the tree. But 10 still needs to be broken down into, Colin?
2 times 5.
2 times 5. And those are both prime, so I can stop there. And again, please rewrite those in order. I've got 2 2s, 2 times 2, 1 3, and 1 5. And that all will multiply to give me 60. Now, Zach Zappia is saying, but Mr. Hahn, you told us there's 2 ways to do that.
But Mr. Honey, first there's.
I did tell you there's, thank you, Zach, for bringing that up. I almost forgot. Where was that on this one? Where was my, oh, 2 ways. All right. Way number 2, under the same notages here. Way number 2 is called division by primes. And maybe you'll like this better, maybe you won't, it doesn't really matter. Sometimes they'll tell you to do it by division by primes, which means you need to do it by division by primes. Okay, and here's the example of that. And it's just like it says. Instead of doing a factor tree, I'm going to start with 36. Instead of doing a factor tree, I am going to just keep dividing a number by prime numbers until I get to a number that is prime, which means this. And the nice thing about this is you can do this a lot. You always want to, if it's an even number, the easiest way to do something to a number to divide it is just cut it in half. So you'd want to divide it by 2. 2 is a prime number, so I can do that. How many times is 2 going to 36? Well, maybe you know, maybe you don't. It's 18. 2 times 18 is 36. Well, as long as I keep getting an answer that's not a prime number, I keep dividing it by a prime number. So 18 can be divided by 2 again, or cut in half, and that gives me 9 as an answer. Is 9 a prime number? It is not, because it can be divided by 3. And then 9 divided by 3 is 3. Is 3 a prime number? Yes, sirree, Bob. All of these numbers on the outside are all the prime numbers that multiplied together would give me back to 36. So those are my answers. 2 times 2 times 3 times 3. And that is my answer. When multiplied, that would give me back to 36. A lot of times people use division by primes when it's like a really big number. Like, for example, what if I was doing, 720? Well, if it's 720, maybe you know this, maybe you don't. I can cut 720 in half. It's pretty easy. What's half of 720? 360. Or you could actually do the division problem. And then I could cut 360 in half again, which is 180. Then I could cut 180 in half again and get
980.
Now we're starting to get. And I could cut, as long as it's even, I can keep cutting it in half again. Half of 90 is, you might want to leave yourself a little more room than I did. 45, I can't cut in half, and it's not prime though, because I can divide it by 5. Why couldn't I do 9? 9's not a prime number. Oh, look, I get 9 up there. Can I stop with 9? Not yet, because I have to divide it by 3. And once my answer is 3,
2 times 2 times.
then I get. So all those things on the outside of my divisions are my answer. I have 4 2s, 2 3s, again, try to write them in order, and a 5. I don't know, do they say write it in exponential form? I don't think so. Sometimes they'll tell you what form to use, sometimes they won't. If they didn't tell me, I'd just pick whichever one I feel. How about this? I'll give you one. 40. Prime factorize 40. Prime factorize. Prime factorize. I'll give you a second there. I would use the tree thing. Well, it doesn't matter. You use whatever you want. You'll get the same answer. You got an answer already? Holy smokes. Must be better than I thought. Tyler, what'd you come up with?
2 times 2 times 2 times 5.
I think you are probably right. You can break 40 into 4 times 10, or you could have done 8 times 5, wouldn't matter. 4 can be broken down to 2 times 2. Those are prime, so I can stop. 10 can be broken down to 2 times 5. Again, both prime, so I can stop there. 2 times 2, 2, stop. Everybody happy?
Yeah. I guess so.